How Climate Change Affects the Ocean's Acidity by Evan Druckenmiller. The problem and question. With climate change becoming more and more prevalent around the world, it is having many more effects on the world around us and the environment that we live in. How will climate change affect the acidity levels of the oceans as time goes on? What other effects will occur as a result from the rising acidic level due to climate change? And what type of ecological impacts will this have on the world around us? There are many questions that need to be answered about how the ocean is going to look in the next couple of years based off of climate change, and how climate change is becoming more and more of a factor towards the environment around us, such as the ocean's acidic level. My hypothesis for this research was if more and more CO2 is released into the atmosphere, which then leads to the oceans, then the acidic level of the ocean will rise as an effect of it. The acidic level in the ocean is caused by the amount of CO2 that is absorbed into the water. If more CO2 is absorbed into the water, then the acidic level will also rise. Some background knowledge. Of all of the CO2 that is within the atmosphere on Earth, the ocean absorbs about 30% of that CO2. The pH scale starts off at 0 and ends at 14. Anything between 0 and 7 is considered to be acidic, and anything 7 to 14 is considered alkaline, and anything 7 is neutral. The ocean's pH right now is said to be at 8.1, which is a little alkaline, but as research shows, as time goes on, the CO2 from the atmosphere is going to come into the ocean and affect that pH. The change in acidity in the oceans can and will be very detrimental to every species that lives in the ocean, from anything big to anything small, no matter what. If it's living in the ocean, it's going to be affected by the acidic level. And as more CO2 is produced and let into the atmosphere, the more acidic the ocean becomes. And the CO2 that is being produced comes from everything that we do in our daily lives, such as driving our cars, heating our homes, cooking, etc. Anything like that produces fossil fuels or burns fossil fuels will release CO2 into the atmosphere. Now here's a short video that I will show. It is just about the acidification.
And too much CO2 in the atmosphere will also alter the very chemistry of our oceans. When carbon dioxide dissolves into seawater, it forms an acid. Just a small rise in the acidity of seawater, combined with climate change, may leave coral reefs, the most biodiverse habitats in the ocean, struggling to survive. But that's just touching the surface. By the end of the century, acidification could leave some types of plankton unable to form their shells. And plankton is at the foundation of nearly all marine ecosystems. If key species of these tiny organisms are lost, everything that depends on them for food could also start to disappear. Carbon dioxide pollution threatens to change life in our oceans out of all recognition within the span of a single human lifetime.
Now that video just gives us a quick little inside look at what acidification is and how it happens and what the effects are. Now, for some of the importance of acidification and how climate change affects the acidity of the oceans, the ocean is habitat to millions of species ranging from algae to humpback whales. Like I said, anything small, anything big is going to be affected. If the ocean's pH gets too high, there will be ecological changes on the world around us, such as crustaceans that build their shells. They will not be able to use those minerals to build their shells because the acidification in the ocean will eat away at those materials and lessen them as time goes on, leaving those animals no place to build their shells, which are their habitats and their protection. And without that protection and habitat, they won't be able to live their normal life as they wish, but they will have to adapt to the changing environment around them. The pH in the ocean also controls all of the growth of unwanted microorganisms within the ocean. And without the balance of the pH, there will be no control of growth, and any unwanted microorganisms can flourish in the ocean system. Here are the research methods that I found that were used to look at how climate change affects the acidic levels in the ocean. One way is by they have ships that go around the ocean and they drop sensors into it, and those sensors collect data such as the pH level, the CO2 within the ocean water, everything like that. And those sensors can be very helpful to seeing how much the acidic level really affects the ecosystem of the ocean. Another way that they collect data is from those floating buoys that are within the ocean. They also have sensors on the bottom, just like the boats that drop them in. They work as the same way of collecting the pH number and all of the CO2 particles that are in the water. There's also lab research that goes on, not just sensors and everything out in the ocean. Lab research is taking place, and they're pumping CO2 into water that they collect and seeing the effects that it has on the water and all the organisms that they collect from the water. There are many other research methods, but these are the ones that I found were the most effective in getting results and answers to the question of how the climate change affects the acidic level of the ocean. Now, for the procedure of this experiment, they set up many big tubes that hold up to 15 gallons of water. They set those up in the ocean, and they pumped it with CO2 levels to change the acidity. They started it off at 8.1, which was the normal pH of the oceans. And after pumping it with CO2, they changed it down to 7.8, which is predicted to be the acidity level of the oceans by 2100. Now, within those test tubes, the ocean water contains tiny organisms and plankton, and the researchers watch as the organisms adapt and evolve in the higher acidity waters. And those adaptations are both negative and positive, as many of the organisms have to adapt living and protecting themselves, and also by now the results from this research have came, and as organisms became more adapted to the acidic water, they began to become less adapted to their normal surroundings, which is the pH level of 8.1. Also, phytoplankton that was collected when they scooped the water into the big tubes, phytoplankton was in there, and as the research showed, those phytoplankton started to bloom, which resulted in them being eaten by other organisms in the water to survive. So those other organisms that were made or forced to adapt from the changing acidic levels found a way to survive by eating the phytoplankton that started to bloom from the higher CO2 levels. Now, as the CO2 gets into the ocean water, it changes the environment around all the species, which results in the species changing their behaviors and interactions with one another. And lastly, the high pH of the water is critical to the offspring of many species, especially those who create their shells to live, as the CO2 breaks down all the minerals that they need to use to create those shells will be depleted as an effect of the rising acidic levels in the ocean, which will maybe even lead to some of these species becoming extinct from not being able to live in their normal conditions. Now here's a graph that shows the maroon purple line shows the CO2 in the atmosphere, and as it rises, and the darker blue shows the CO2 within the seawater, and as that rises as well, the seawater pH declines. Now, this goes back to my hypothesis, as the more CO2 that is absorbed into the water, the more acidic it will get. And this graph shows that by the pH going down lower and lower, closer to being acidic. Now here's another graph that shows the same thing, how the pH starts at 8.1 and it falls all the way down to 7.8 over time. And the dissolved carbon dioxide starts low and goes all the way up. And as the CO2 rises, the pH line is falling. Now some further research. Based off all the results from the research, it was clear to say that climate change will be very problematic as it causes the acidity of the ocean to rise. Within the unusual amount of CO2 in the ocean, the organisms that live within it will have to adapt to the changing environment around them. And scientists are still trying to see if in 100 years every organism will be able to adapt to the changing environment around them, not just certain organisms or a select few of organisms, but all organisms. And my hypothesis of if more CO2 is released and absorbed into the ocean, then the acidity of the ocean will increase as a result was correct, because the graphs that I just showed show that as the CO2 levels rise, the pH line lowers, making the oceans more acidic as time goes on. Now, in conclusion, the data that I collected and I researched, the data shows that my hypothesis was correct, and that with more CO2, the acidic level will increase. And as an effect of the acidic level increasing, every organism around it is also going to be affected by it, negatively or positively, but most of the effects have been negative that are shown in research. And scientists are still trying to find ways to stop the climate from rapidly changing and stop CO2 levels from being absorbed into the oceans, which will then ultimately make the acidic level of the ocean stay at 8.1, which is suitable for all of the organisms living in there right now. But if the effects of climate change don't lower and they keep rising, more and more CO2 will be pumped into the ocean, causing all of the species within there to just be completely depleted, because they will not be able to survive.